Hello everybody, welcome to Transy Learning Physics videos. Today we'll be discussing about practice problems related to SUVAT or kinematic equations for body moving horizontally. So let's see what all questions we'll be covering in this video. The first question: the driver of a train at 40 meters per second applies brakes as the train enters the station. You can see here a station and the train is just entering the station, and at that moment the driver applies the brakes and the train slows down at the rate of 2 meters per second squared. So as per the question, if we consider these 3 points, then the initial velocity of the train is 40 meters per second because the driver applies the brakes as the train enters the station. So on applying brakes, the train will eventually stop and the final velocity will be 0. And as the train slows down at the rate of 2 meters per second squared, so here the acceleration will be negative 2 meters per second squared. That is retardation, or what we call deceleration, because when applying brakes the train slows down. And the platform is 400 meters long. The length of this platform is given as 400 meters. So now the question is, will the train stop in time or not? So what parameter we should consider, what we should find to find this answer? We need to find the distance traveled by the train after the brakes are applied, because once the driver applies the brake, it will not stop immediately. It will take some time for the train to stop because it is slowing down at the rate of 2 meters per second square. So the criteria is if the distance traveled by the train is equal to the length of the platform, which is 400 meters, then the train will stop in time. That means still here. And in case the distance traveled by the train is less than the length of the platform, that is 400 meters, that means it will stop somewhere here in the middle of the platform. And in case the distance traveled by the train is greater than 400 meters, that means it will not stop in time. It will stop after it has left the platform. So this is the basic criteria that we will be following to solve this question. Now to solve this question, first of all, we will write it down what is given and what needs to be found. So here, the initial velocity of the train is 400 meters per second, and once the brakes are applied, it will eventually stop. So its final velocity will be 0. And as it is slowing down at the rate of 2 meters per second square, so the acceleration will be negative 2 meters per second square as the acceleration is decreasing. So it is retardation or deceleration. And we need to find the distance traveled by the train. So now, which of the 3 SUVAT equations we should use to solve this question? Here, u is given, v is given, and acceleration is given, and we need to find the distance. So we cannot use this because there is no parameter of distance, so either we can use this one or this one. And as the time is not given to us, so we cannot use this SUVAT equation, so we will be using the equation v square minus u square equals to 2as. So I will just put the value, that is 0 square minus 40 meters per second square equals to 2 into minus 2 meters per second square. So this will be minus 40 meters per second into 40 meters per second divided by 2 into minus 2 meters per second squared. That will be the distance. So on solving this, we will get the value as distance equals to 400 meters. So the length of the platform is 400 meters and the distance traveled by the train is also 400 meters. So the train will just stop in time. Next question: a girl running a race accelerates as 2.5 meters per second square for the first 4 seconds of the race. Here you can see 2 girls. Let us consider this one. This is a girl which accelerates at the rate of 2.5 meters per second square. Accelerates, that means this is acceleration is given as 2.5 meters per second square for the first 4 seconds. Time is given as 4 seconds. So how far does she travel? So if we consider these 3 points, then the initial velocity of the girl will be 0 because initially all 4 of them will be be at rest. And once the race started, they started running, and this girl started running a race accelerate at 2.5 meter per second square for the first 4 seconds of the race. So first of all, we should write it down what is given and what needs to be found. So initial velocity is 0, time taken is 4 seconds, and she accelerates as 2.5 meter per second square. And we need to find the distance, because in question it is asked how far does she travel in time. So we need to find the distance traveled by this girl. So now, which SUVAT or kinematic equation we should use? Here we need to find the distance, so we will not be using this SUVAT equation. And here initial velocity, time, and acceleration is given. So we cannot use this equation because here the parameter of time is not given. So we will be using this SUVAT equation to solve this question. So this is S is equal to ut plus half at square. So the distance traveled by the girl will be 0 into time plus half acceleration is 2.5 meter per second square into time square, which is 4 seconds into 4 seconds. So on solving this, we will get the value as 2 meters. So the distance traveled by the girl is 20 meters. Thank you very much for watching this video. For more videos, you can visit our website transalearning.com. Have a great day.